Okay, let's give you guys some practice. So work out the surface area of e to the power of x from 0 to 1 being revolved 360 along the x-axis. So we're going to revolve it 360 along the x-axis. So work out the surface area of this thing here. Okay, so remember, this is the arc length. So in your mind, you've got to cut up into lots of strips. This thing here is the arc length. Once you've got the arc length, you need to 2 pi r it to get the circumference. So times it by the circumference, which is this thing here. But r is the height. R is the height of this thing, which happens to be y. So that's why this y here is the 2 pi r. And this is a constant, you can take it out. Well, we've seen this before. I'm expecting you to know this. So work out the surface area from 0 to 1. So press pause and have a go. Okay, so to do this, well, you're moving along in the dx direction, and your tracker is x. So suppose x is here, the height. Well, let's look at this strip here. Suppose x is here. Hang on. Suppose x. Let's just look at this one particular strip here. You remember, you're summing up all the strips. So this is x. So you're moving along the dx direction. So let's say your tracker is x here. You need to know the height of this thing here. The height is given by this. So which is this thing here? Which is this thing here? Well, anyway, once you know the arc length, because this is the arc length, this thing here will give you this arc length here. Once you've got the arc length, 2 pi r it, which is this thing here, and then the r is the y. So anyway, it will give you this. The surface area is given by this thing here. So we need to know we need to know dy by dx. So remember, y equals e to the power of x. So dy by dx equals e to the power of x. But then we need to square it. So that will then give us this. This whole thing here will then give us this thing here. And then, well, we could write this as e to the power of 2x, but leave it in this form, because notice that this is exactly the same as this. So we've got to use substitution. So let u equals e to the power of x. So now du equals e to the power of x dx. So here you've got this block multiplying with this block, multiplying with this block. These two blocks are being multiplied together, so that's like these two blocks. So you can put that into here. That will then give you this, and then this block here. Well, you've got 1, 1, and then put the u into here. That will then give you this. Okay, so that will then take us to here. Remember, we made this substitution, so we're working in terms of du. But let's leave this as x equals 0, x equals 1. Later on, we're going to convert everything. Instead of working in terms of u, later on we're going to convert everything in terms of x, and then we can put the 1 into the x, the 0 into the x. But at the moment, we're working in terms of u. So we now need to integrate this. So to integrate this, create a triangle in such a way that this thing here will be true. So if you make the opposite to be u, the adjacent to be 1, then the hypotenuse will have no choice but to be square root of this thing squared, this thing squared. This is using Pythagoras, high school Pythagoras. So now we need to extract this du. So now let's look at this. Well, tan theta is given by u over adjacent, which is u. So now differentiate this side. That will then give you this. Differentiate this side. That will then give you this. So now we can put this into here. And then looking at this complicated thing, well, look at the diagram. The complicated thing is this thing here. So if you look at secant theta equals the complicated thing over 1, which is that complicated thing. So now you can put this into here. Remember, this thing here goes into this, so this thing here will then become this. Tidy it up. That will give you. That will then give you secant to the power of 3. So now I'm expecting you to know this because we've done this many times in the past. I'm expecting you just to know this. If you can't remember, just look it up on the internet. If you integrate secant to the power of 3, it will give you this complicated thing here. And I've already done a video on this. So integrating this thing here will then give you this. Will then give us this. Remember, we are working in terms of theta, but then earlier we were working in terms of u. So we started out with x. We made the substitution u. Now we made another substitution theta. Later on we will need to go back to u, and then later on we will need to go back to x, and then we can put these two in. Okay. Well, by the moment we're working in terms of theta. So integrate this. That will then give us this thing here. So hang on. So now factor out the half, because you've got a half here, so you can take it out. It will cancel out the 2. That will then give us this thing here. Now we need to convert everything back into u. So if you look at, you've got one block here, you've got another block here, and another block here. So if you look at secant is this thing here. So that's hang on. So secant is this block here. And then if you look at tan is this thing here. Tan is u over 1, which is u. So this block here is this. And then the secant is this. So that will then give you this. And then tan is this thing here. So remember, now we're all in terms of u, but remember we're integrating from x equals 0 to x equals 1. Now we need to convert everything back into x. But then right from the start we said let, remember right up there we said let u equals this thing here. So now we need to put this back into the u, put this back into the u, put this back into the u, blah blah blah. This whole thing here will then become this. Now everything now is in terms of x, so we can put this, we can start putting this into the x, put this into the x, put this into the x, put this into the x, and then take away, and then put 0 into here, put 0 into here, put 0 into here, put 0 into here. That will then give us this whole thing here. Okay, so hang on, let me just tidy this up. Hang on. Hang on. Hang on. Hang on. Okay, that will then give us this thing here. But then if you look at this thing here will never be a negative, so we don't really need the absolute here. This thing here will never be a negative, so we don't need the absolute here. So we just need to replace it with brackets. Okay, so your final answer will be given by this.